guys, welcome to this first long form video of my CPU project. I've already written some code as you can see, and I'm going to explain what it all does before I add in more code on the video. So basically, first up I have my list of what I'm calling my boot variables, which which are very important for things like my arithmetic logic unit. Like for example, I have AN and BN, which is the sum of what our 8-bit word is valued to. And then we have our C out, which is the sum of what our output is out of the ALU. And then down here I have the variables for my ALU written out here, which are A and B variables, just like up here. And then I have my B variables. And down here I have what I call my ALUC, which is my arithmetic logic unit control. And right here I have program codes. This will be 3 bits of binary until I add in a divide, which will be kind of tedious to do as I have to add decimals. Then because I do want to try and build all this stuff in real life eventually. And then over here I have my A register, and what this does is if my input for such as bit 1 is high or 1, which is true with voltage, it adds 1 because bit 1 is equal to 1 in binary. And then bit 2 is equal to 2, bit 3 is equal to 4, bit 4 is equal to 8, bit 5 is equal to 16, bit 6 is 32, bit 7 is 64, and bit 8 is 128. And then down here I have my B registers. And now we need to work on what I'm calling my function registers for the ALU, which up here are going to use my program codes that I've made to add, subtract, and multiply. And the max of one 8-bit number is 255. So 16 bits of binary, I forgot how much it was. Well, I don't remember, but basically I have 2 different binary strings right here, and combined together for adding is 510 because 255 is the max of 8-bit binary. And this 8-bit binary input will use the voltage to trigger ones and zeros if I actually build the CPU instead of being all digital, because basically everything that happens past this point up here, except for these up here, that happens in the chip. Like all this right here is inputs, and these are inputs, and then this is our internal computing. But now we need to work on our function registers, and we need to remember what our code is. And to do this, we're going to use our if statements up here. So 1 or 0 is adding. So basically what I need, or 0 is absolutely nothing, which means the ALU is off. So what I'm going to use an if statement, and then I'm going to put in our variable, and then 2 equals. And what this does is that now if my ALU control variable is 0, I can trigger a reaction with that with this if statement, which I go down like this. And then I've put in console.log, which logs text or variable to the console. And what I do after that, hold on, it's not supposed to be assert, it's supposed to be log. And then I put in I forgot what commas. And then I put ALU is off to tell tell whoever's using my CPU that the ALU is off. And then what I do is I press F5 to run my program, which I just realized that can't show currently. And when I press F5, it should show up. Hold on. Well, anyways, it does work now, as it shows ALU is off. And sadly, I can't move the thing around that I'm recording with currently. And basically now what I need to do is I need to get to my adding statement. So if ALUC equals or double equals 1, then we do console dot log ALU is adding, because that's what our program code I wrote up here is just 1. And then we come down here, and then what we do is we redeclare our variable, which is C underscore out is our output variable, and then we do an equal sign, and then we do A underscore N plus B underscore N. And now what I can do is I can basically run this now to set C out to 255 plus 255, because if we go all the way up here, all of my variables for A and B, or all my variables for A and B are set to 1 right now, or true and binary. And now what I need to do is I need to get to my my subtracting part. And my subtracting part will just be basically the same as the adding part, console dot log, and ALU is adding or subtracting, sorry. And then C underscore out equals A underscore N plus B underscore N. That's not an under. And I need to switch this up for subtracting. And now what we need to do is we need to work on our multiplier. So we go if ALUC equals 111, which is our program code again. And then we go down again. And I'm going to end this video real quick and pick it back up later. But I hope you guys